Hello everyone, you're welcome to our physics practical class today on simple pendulum experiment. This experiment is going to give us a guide on how we are going to be able to obtain physics practical table without going to the laboratory, without having any apparatus. And then the essence of this practical is for you to understand, to know the rules guiding a given practical, so that even if you are performing the experiment, you know when you are doing the right thing and when you are not. And then it can even help you to obtain tables without performing the experiment, and it will save time for you. So stay tuned and learn how we're going to do this. But first thing first, if you have not subscribed, please go and hit the subscribe button and then the notification button so that you will get other videos as they come. Watch and see how we're going to do the magic. Okay, in this experiment, let us see the question. The question said you are provided with a pendulum bulb. A pendulum bulb is this bulb, a meter rule that is going to be used to measure the length of the thread, a stopwatch that is going to be used as a measuring instrument to measure the time of oscillation, a retort stand. This is a retort stand with a clamp to suspend the pendulum bulb on. Then another necessary apparatus like your mathematical set, your ruler, your calculator, and other things that will be needed in this practical. But you know what we are going to do is calculation. Now there are rules governing every physics practical, and there are formulas that guide them. If you know these rules and know these formulas, you don't even need to go to the lab to obtain the tables of any experiment. All you need is to know the rules and the formulas and know how to use them. In this particular simple pendulum experiment, what is going to guide us on obtaining table? First of all, let us see what the question said. They said adjust the pendulum such that AC, which is equal to L, AC, which is equal to L, equal to 90 cm, okay, displace the pendulum bulb slightly such that it oscillates in a vertical plane. Displace this such that it begins to oscillate, and measure and record the time, small letter t, for 20 complete oscillation. Now they have given us the length of the thread, and they say we should oscillate and measure the time for 20 oscillation. An oscillation is a to and fro movement. So if a pendulum bulb is displaced and it goes this way and returns back to where it is coming from, it has taken one oscillation. And that is what it does for 20 times. You'll be counting it for 20 times and read the time taken to cover these 20 oscillations. You record it. Then they said you should evaluate capital T, which is the period, and the square root of the length. These things that we are asked to measure and evaluate will form our table. The first thing we are going to have on your table is the given value. That is the length of the pendulum bulb, the pendulum in centimeter. And that is the first column. They said 90 centimeter. Okay. Then they said when we displace it for 20 oscillation, we determine the time, which is also in second. And then we have another column also where they say we should evaluate the period. The period is the time, from definition, is the time taken to complete one oscillation. That is time over number of oscillation, also in seconds. Then we're now asked to evaluate the square root of the length, and this forms the table of this practical. Then they now went ahead to say we should repeat the procedure for 4 other values of L, 80, 70, 60, and 50. 4 other values of L, 80, 70, 60, and 50 centimeter. These are the values of L. Now, I advise my students that the given values, when I call the given values, are values that are given in the question, should be in 1 decimal place. So this should be 0.0, even though it was not written that way on the question, it should be 0.0. Okay, and then the calculated value is the next, the measured value, sorry, is the next one, which is this. The value we got from a measuring instrument. Now, these 2 values are the values we are going to tell you how you are going to get it without going to the lab. Of course, this one is not relevant here. This one is just to find the square root of these values. That will give you this square root of L. You can see that. So, how do you obtain this? From the experiment, you obtain this one by displacing the pendulum bulb, and it will oscillate for 20 times. And that 20 times, the time it took to oscillate 20 times, is what you're going to write here using your stopwatch. Then after you've gotten the values here, you calculate using a calculator by dividing whatever you have here by 20, because n is 20. We have 20 oscillations. That will give you here. Whatever you get here divided by 20 will give you this other one. And that's how you would do to obtain these other values. But I want to obtain these values without performing this experiment. How am I going to do that? I said you need to know the rules guiding this practical. And this practical, the rule guiding it is that there is a relationship between the period, the square of the period of oscillation is directly proportional to the length of the pendulum in meters. The length of the pendulum is in meters, while the period is in seconds squared. The period squared of oscillation in seconds squared is directly proportional to the length of the pendulum in meters. Okay, and you know that in mathematics, if we remove the proportionality sign and introduce an equality sign, you have a constant introduced, and this constant in this experiment is equal to 4 pi squared over g, then the length. So this is the constant, where g is acceleration due to gravity. For the calculation's sake, we use 10 as an approximate value of acceleration due to gravity, so it is also regarded as a constant in this instance, even though it is not necessarily a constant. So period will therefore be, if we remove this square root, this square here, we are going to find the square root of these other values, 4 pi squared over g, and then L. And this will give us the square root of 4 is 2. The square root of pi squared is pi. But we can't get the square root of L and the square root of g. So these ones remain in the square root. So we have period equals 2 pi square root of L over g. Some of us might have seen this formula, but we don't know how it came. You can see what is happening here. So, but you know that this g is a constant. So we can move it back here. So that I have period is equal to 2 pi root g, then root L. So what I will do is to obtain this value and then use this relationship to obtain my period and my time. So the period equal to 2 pi all over the square root of 10. I said acceleration due to gravity, the approximate value is 10, then root L. And what I have calculated here, 2 pi over root 10 is equal to 1.987, then root L here. So this is the formula we are going to use to obtain the period and subsequently obtain our time. How are we going to do that? Okay, let us begin. The first value I have as my length is 90 cm. So I said at L equals 90 cm. But remember I said that this L should be in meters. So it is going to be 0.9 meters. The period will be equal to 1.987 root 0.9, and the period equals to this times this. I obtained 1.885. So the period is going to, for 90 is 1.885. You do the same for at L equals 80 cm, which is equivalent to 0.8 meters. The period will be equal to 1.987 root 0.8, and what I obtained is 1.777, and you write it here 1.777. Then at L equals 70 centimeter, which is 0.7 meters, our period is going to be 1.987 root 0.7, which I obtained 1.662. You write it here 1.662. Okay, at L equals 60 centimeter, which is equivalent to 0.6 meter, the period will be equal to 1.987 root 0.6, which I obtained 1.539. 1.539. I did the same for 50 and obtained 1.405. Then, since I said if we perform this experiment, what we are to do is that as the bulb is oscillating, our stopwatch is reading, and after 20 oscillation we pause the stopwatch and check what it has read. What the stopwatch read is what we are going to write under small letter t, and after that we divide small letter t by 20 to get this capital letter T. So if it is this divided by 20 that will give us this, Then this times 20 should give us this other one. So we have to multiply everything here by 20 to get the time. So if I multiply 1.885 by 20, I obtained 37.70. Multiply 1.777 by 20, I obtained 35.54. Multiply 1.662 by 20, I obtained 33.34. Multiply 1.539 by 20, I obtained 30.78, and this one I obtained 28.10, and I have obtained my table. I said this one is not what I'm going to do here. This one you can actually do. It is the square root of this because it's root L and this is L, the square root of this. Okay, and you obtain this other one. You can see how we are able to obtain the time and the period of a simple pendulum experiment without going to any laboratory. It didn't take us any time. So this is what you can do in every physics practical without going to the lab, without having the apparatus, and you are good to go. Once you know the theory, you will know the exact value you are meant to obtain. Now there is something that is very significant I want us to know. I have told us that there are three major values that are obtainable in physics practical. And what are those values? The given value, the measured value, and the calculated value. The given value is the one that is in the question. The measured value is the one you use a measuring instrument such as stopwatch, meter rule, and whatever measuring instrument to obtain. While the calculated value is the one you evaluated. It's that the question will say evaluate this and that. The question said evaluate period and square root of L. So these two are calculated values. The capital T and root L are calculated values. The small letter t is measured value. We measure from a stopwatch, and the small letter, this L, is the value given in the question. So now you can perform this experiment. You can do this in your laboratory and see if the values you are going to obtain is similar to what I have here or different. Now what I advise my student is that your given value should be in at least one decimal place, your measured values should be in at least two decimal places, your calculated value should be in at least three decimal places. That is what I advise my students to always do. It will make you have accuracy, and consistency is very important in physics practical exam in WAEC. If you miss, or if you are not consistent in your decimal places or your significant figures or your units, then you lose marks in every column. And then the trend is also necessary. If it is meant to decrease and your own decrease and sometimes increase, it becomes an issue. It's going to affect the entire experiment. So you can see how we're able to perform this practical without going to the lab. We are going to discuss other parts of this experiment where we are asked to determine the slope, to measure, to plot graphs. We explain all this in subsequent videos, but for now what we are here to do is to show you how we can perform a simple pendulum experiment without going to the lab, just by using this relation T equals 1.987 root L, where L must be in meters and it must be the length of the pendulum. So if it is given in centimeters, you will change it to meters. If it is not this value that is given, even if this is labeled H, it's still the L because that's the length of the pendulum. If you are given another length, maybe you are given here as the values in the question, don't use the values given here as the length of the pendulum, because this L must be the length of the pendulum, which is from where the pendulum is suspended to the center of the bulb. Enjoy your day.